Testing. Hello. Okay. All right. You can hear me. Yeah. So 6:13. So we probably should start now. And just to make sure, is the stream started already? Okay. Great. Thank you. So welcome everybody to CJARC tonight, and it's the first one of 2025. So Happy New Year to everyone. Thank you so much. And if you haven't already got food, you all know what the food is, the pizza. And thank you so much again to Endor Labs, who's sponsoring tonight's meetup and also getting all the pizza and the goodies too. Actually, it's more than what we normally get with all the sweets too. And so that's nice. So thank you. Okay, so tonight we have Darren Meyer. Did I say your name correctly, Meyer? Yeah, from Endor Labs. And his topic is on upgrading socks, identifying working changes with program analysis. Oops, let me go to this page. Okay, so first of all, this is our usual thing. We get sponsored by JetBrains, and they donate 2 JetBrains licenses to us. And there's some expiration date too, so make sure if you win it, then make sure you activate it by the end of the month. And so if you are interested and you haven't already won anything within the past 9 months or so, we have a cooling period. So you're welcome to enter into this drawing, and we will have 2 to raffle out for tonight. So yeah, I'll let some of you, if you are interested. Let's say if we only have 2 people or less, then actually you can just claim it too. So that will be good. Your probability will be, 100%. Okay, so let me make sure. Okay, cool. If you need it again too, I'll share that URL so you can get to our slide deck. So, okay, so just some housekeeping. Remember that we have our Chicago Tech Slack, and if you'd like to join, that's the community Slack. And then also the Chicago, well, there's also a Java Off-Heat podcast is by Freddie Gimay, who was the CJUG president before, and he now actually from CJUG to CJUG, and is Seattle JUG. That's where he's moved to because he works for Expedia, and he transfers to headquarter Expedia. So he's out there helping out with Seattle JUG, but he continues to run this Off-Heat podcast, and is actually very good. So if you don't know already. And then we are on meetup.com if you'd like to join us there. And we're going to try to use other platforms too. For example, Nitin, who's our helper, helping to set up on Luma too, if you're familiar with that platform. So we're also on X or Twitter, and this is our handle if you'd like to follow us, if you aren't already doing so. And then we also have our Discord channel. If you haven't already joined us there, that's the QR code and the link to join us. And also, too, every time we like to create a room for discussion. So if Darren, if you'd like to get an account, and if folks have questions that that are specific to today's meetup, you're welcome to use that room, which I usually set up with the date and also the title of the the presentation. So okay. Okay, some community info. So we are a community partner of the following groups, which currently is the JetBrains. We all know them. And then also a devitjobs.us, and they have jobs from listing from all over the world too. So you can check them out. Upcoming events. Next week, Thursday, we have the Chicago Kotlin User Group. And by the way, and John is one of the leaders here, John. And Amanda will be the one, Amanda Hinchman will be celebrating her new book on, I forgot exactly the title, the multi-platform or something. Yeah, it's a Kotlin specific. And she'll be running a workshop that will be at IIT, the Illinois Institute of Technology. So you can check out our website to get information on that and register for that too. And then in February, we'll have a speaker from the Norfolk Just Up, the Great Lakes Symposium. We don't know who yet, and actually I'll be speaking there too in May. So I don't know if I'll be speaking there, but somebody will be doing a talk too in February. And then in March, we have actually, initially we have Alina, if you're familiar with, if you work with GraalVM, and she's the well-known GraalVM advocate from Oracle. She'll be at JavaOne, and by the way, JavaOne has resumed in March of this year by Oracle, although they have a more tailored program this year. Alina will be here from Europe, and she's planning to come and visit us. Although I think there might be some issue right now, so she may or may not be here, but stay tuned. Otherwise, too, we also have Pasha from Belsoft too. And Pasha also is a Kotlin expert as well. So he may have a topic about Kotlin. And then other confirmed speakers, actually, I should say, is just Josie Pomalt, based in France, and he's an Oracle Java developer advocate. And then also Jared Grunwald from Azul, and also Temporal too. They will be sending a speaker to us. And then we still are thinking of a meetup, and we're just trying to get enough interest, right? If there are enough people, we can do an conference style meetup too. So for those of you who are new to conference, it just means there are no set topics, but the participants will vote on certain topics that matter to you, and then we vote on it, and we'll form discussion groups around it. So we'd like to do that if there are enough interest. So let us know if you're interested. And then this is just more information about the Great Lakes Symposium that will be on May 16th and 17th in Chicago, and that will be at Itasca. And they have been doing it for a while, and it's organized by No Fluff Just Stuff, the developer conference people from Denver, Colorado. And it's been very good. I've been there too. Lots of good talks. And for example, Dr. Venkat will also be speaking there. A couple of well-known speakers too will be there. And then there are special perks that they like us to share with you. Is if you want to register early on before February 14th, you get a big discount from that. And then Chicago Jug will get a $100 discount. You can use the promo code that's listed here. And again, I'll be sharing the URL so you can have access to this slide deck without having to copy. There are also group discounts if you'd like to bring your work team to that too. And if you are interested in speaking at CJUG, please feel free to submit your proposals to this present@cjug.org. For job seekers and recruiters, if you like to kind of find jobs or looking for candidates, please sign up with our CJUG group on LinkedIn. And this is the QR code and also the LinkedIn CJUG group that you can join us. Okay. And now actually it's no longer new, it's the Neo4j who is our gold sponsor. They'll be sponsoring us again. So I wanted to post their contest. They have this monthly raffle that they would give out, for example, things like drones. Although this slide, I have to admit, is a little old. I tried to get a hold of them, but they definitely, if they're running it, they will have this, some fancy gift that you can get, right? The chances. So feel free to enter into that raffle. And today's venue host is Microsoft and Chicago, and thank you so much to David Giard. So he's out there because he has to go to London, so he's like planning his trip today. But if you've seen him, say thank you. Please tell him thank you. Yes, he's been a big help for us. And he's a partner cloud solutions architect at Microsoft. Friends of CJUG, so just wanted to bring to your attention, these are the worldwide, Java community, but the ones like Atlanta Java, Boston, Garden State in New Jersey, Kansas City, New York City, Java State, and Pittsburgh and Portland. Actually, supposedly the Portland Java person would be here, but I think he couldn't Sean, but then I don't think he's able to come. But I want to thank you all, and you can check them out. Some of them are doing virtual meetups as well. Okay. And now our speaker from Endor Labs, Darren Meyer. He's a DevSecOps research person, and then also an application and product security leader at Endor Labs, and experience in supporting product development, education, and community advancement, and specializes in software development, application infrastructure, technical operations, and product security and related disciplines. So we're very happy to have you, and the stage is yours, Darren.
Thank you.
Thank you. I'll let you switch it. Yeah, thank you. Thank you.
Can everybody hear me okay? This mic is not the world's best, so if you have trouble hearing me, give me a sign and I will shout louder. I have twins, so I am used to shouting. It is fine. So I want to talk to you about something that is near and dear to the heart of every developer who's ever used a dependency in your entire life, and that is that upgrading sucks, right? Especially if it's something like Spring Framework, right? Like, I was just out of curiosity, how many people in here actually have found a strategy for developing JVM related stuff where you actually stay up to date on all your dependencies? Really? Can you tell me a little bit about it? Okay, so you're cheating. Good job.
They tend to be in small increments that are easier to handle, as opposed to trying to build them up. And now you have a whole lot to figure out. It's hard.
Anybody who's done any kind of maintenance on like enterprise legacy stuff has wished that their predecessors had done that. But it takes a lot of time still, right?
Yeah, I mean, it's a lot easier once you get into the habit of it. I mean, it's the same thing like with upgrading your servers.
Yep.
If you have an auto upgrade going every time you go into production, you're never going to have a problem, especially because then you can also test it in lower environments. But if you let it go for any period of time, then it gets hard. And so, yeah, it's just discipline.
Advocating for engineering discipline. Fantastic. How many people feel like their bosses would support that? A couple of people. All right. Like that's the real problem, right? Upgrading sucks in part because you're supposed to be delivering features. You're supposed to be spending this time. And also, like, does anyone actually like doing the upgrade work? I never did. I always hated it. Right. And how many of you guys like are running upgrades because your security team is like, oh, there's a vulnerability? No, so the rest of you are just ignoring those, right?
What if you're the
Then you're me. Then you stop being a developer and start being a security guy, right? So speaking of which, why should you listen to this nerd? So I've been a software engineer for 25 years. I kind of go in and out of software engineering as my main job. I've also been doing application security for 20 years. Yes, that's an overlap. I'm not that old, right? So a lot of what I've done in application security has been security research and figuring out what are developers doing that introduces vulnerabilities, right? And this isn't like, oh, developers are making mistakes. It's like, hey, where is the behavior that's causing this? How do we make that easier? How do we make paved paths? How do we make secure way the easier way? So I spent 8 years doing research and development on that. I've run AppSec programs for everything from tiny companies as startups to Fortune 50 companies that you've probably heard of. You can go check out my LinkedIn if you want. And I've seen this from both sides of the aisle, and I absolutely hate everything about managing dependencies. The thing I hope AI will someday solve for us is never having a dependency again. I'm not holding my breath, but that is my dream. All right. Why does upgrading suck so bad? I'll tell you a story in 3 parts. We have a bug. It was introduced in 2.0. It was fixed in 2.2. Surely nothing will go wrong, correct? Right, that's a minor update, right? Should be fine. Yeah, so that's that change. That is 5,000 files have been changed. And like, I'm sure you've reviewed that PR before in your life, right? This is, by the way, how you sneak stuff in. You make a PR this size and no one will review it, right? So, oh, and by the way, I'm the security guy, and I'm telling you, you have at minimum 139 of these, maybe 200, depending on how good I am at my job, right? It's not going to happen. Like, you're not going to do that. What's going to happen when you see this situation is one of 2 things. You're going to pick 3 or 4 things that you think are important or critical or worth your time. You're going to try to fix those, or you're going to throw the entire thing in the trash can and move on with your life because you haven't been hacked yet, right? So we decided to fix this a long time ago, right? We just use Semver. It'll be easy. Anyone not familiar with Semver? Just out of curiosity. Okay. So yeah, the idea behind Semver was like, hey, we have the 3 versions. We have the major, minor, and patch, and patches are always non-breaking changes. Minor is probably not a breaking change. There is a small risk, but we haven't put that much stuff in. It should be okay. And then if there's a breaking change, we're going to bump the revision, which is why Spring Framework is at version 3, right? They've only broken things 3 times, right? And it's damn lies in marketing, right? Like everyone's going to use this thing. No, we use this, right? This is reality. Tell me where the lie is, right? This is the shame version, right? This is, oh, I made an update. I guess I have to bump the version, but I don't really want anyone to know I made a patch. This is like, oh yeah, okay, it's a release. And this is like, yeah, we did a really cool thing. Where's the lie? Right? So like, there's a bunch of things like everyone's not going to use this. I don't care how disciplined you are as an engineer. Nobody actually uses Semver. In theory, sure, but in practice, no one's actually doing it. No one has the discipline. And even people who are trying, you get stuff like this where aggregate patches, like 2.7.123. Really? You've made 123 patches and you're going to guarantee me nothing has broken in 123 releases. I don't believe you, right? No one's regression test suite is that good. And if it is, come work for us, please. We could use that. And then of course there's the marketing thing. So if you have something like Spring Framework or something big where you've got a marketing department behind it, you can't update your major version because we just spent $100,000 telling everyone to upgrade to one major version. You're telling me there's a new one because you broke something? Like that's not what breaking changes means, marketing department, right? And like it just doesn't happen. And even if it's just an open source project, like, yeah, man, I don't want people to feel like they can't update because we're going to get the Spring Boot problem where everyone's still on Spring Boot 4 and we want to get on 5. We finally get a good adoption and 6 comes out, right? Like stuff like that happens all the time. It's a marketing problem. People don't update. People are reluctant. It just doesn't work. So as a security person, right, I need people to update. There's vulnerabilities in this stuff. Surely we can automate it, right? Software is always clear and composable, and we can just automate these. And Dependabot tried this. Dependabot's good stuff, by the way. But there's a reason that when GitHub partnered with us, they recommend us as an upgrade, right? And it's because this doesn't scale. It just doesn't. If you turn Dependabot on a legacy thing where you haven't been doing your thing of keeping up to date, you're going to get hundreds of PRs. You know how developers respond to this list? They go and find the checkbox that says don't do that anymore, right? It's not workable. And there's good reasons for it, right? It's not in most shops workflow to just randomly review PRs that come up from bots, right? Like how many of you are, okay, you do a PR, how many of you get your PR, your people, like your peers to like respond to the Slack message or the whatever happened when you submitted the PR and they review your PR right away without you hunting them down? Yeah, it's never happened to me either, right? So like you're just not built to be like, no one's going in going, where are the PRs, right? I want to check all the PRs and make sure my inbox is empty. It never has happened in the history of ever. It also kind of assumes that your unit tests are good. Because like you do your PR, you do auto PR like this, oh, I'm going to update your version. And great, the PR checks run, and if they fail, absolutely decline the PR, right? But the security vulnerability didn't go away then. I've never known a developer to go like, oh, that seems really serious. Maybe I should try to fix it. Why? Right? If no one's making you do it, you got better stuff to do. And then if it passes, you're like, great, I'll merge it, right? That assumes your unit tests have covered everything it could break in that upgrade. What's the chances of that? 80%? Are you going to take a 20% chance of breaking prod? I'm not. I don't want my name on that PR that says I approved it and merged it. And I don't have time to test it and run through it and do all the manual testing that it requires for me to be like, yes, I'm confident in this. And I'm envious of you folks who've gotten stuff good enough that your unit integration tests are automated enough that you can just push to production and it's fine as long as the checks pass. I admire the hell out of you. That is not most people, right? Most people are not there yet. And then there's the side effect that nobody talks about. Every single one of those things spooled up at least one runner and ran for 10 minutes, half an hour. Depends on your build, I suppose. Right? How long does Maven clean package take for you to run? Not to mention all the other quality checks in unit test suite that you have to run, right? That gets expensive really quickly in somebody like big finance company. All right, you got big banks or big tech company, Microsoft, right? Microsoft can afford it because they own GitHub and because they own Azure, right? But like most people don't own their own Azure, right? They're paying for those runners. That gets crazy. And especially if you're not actually then merging those PRs on a regular basis, you don't have buy-in from the dev org, you're running all this for nothing. And people just turn it off. It doesn't help you do the thing, right? Why is that so risky though? Like it seems like it should be obvious, right? If I stay up to date on my updates, there should be few changes. They shouldn't break, right? Why does it still do that? Because like it still breaks sometimes for you, right?
Using Apache config, and we couldn't update a small point version. And I couldn't figure out why until eventually, after tearing everything apart, I realized that previous developers had somehow relied on a bug in the system. Well, yeah, they misconfigured the configuration file and it triggered a bug, and so it worked, but it never worked.
Isn't that lovely, right? Like development is hard. Like that's the reality of it, right? And your security team maybe you're lucky, maybe your security team understands that. But if I'm honest, like having worked in both sides of this divide, I'd say generously 5, maybe a little bit more % of AppSec people have done some kind of software development for a living at some point, right? You've got a lot of organizations, the people from AppSec are either straight out of college, and if they've written code in college, they went to a great college. A lot of them aren't. Or they've been grabbed from like NetSec or Ops and been like, AppSec's your problem now. They don't know what they're doing. They'll be the first to tell you, like, we're in over our heads. It is very rare to find people who can code, who want to stop coding and do security stuff. Like, how many of you guys would be interested in the security career? Yeah, that's what I thought, right? It's boring. It's boring to go around telling people no. So in order to understand as a developer, someone says, hey, I want you to do this big upgrade. If I want to understand my risk, I need to answer a few questions. What exactly changed? How risky is that change kind of in general? Is there a lot of code change? Was it all refactoring? Are there method signature changes? Like what exactly happened here, right? I can't just go, oh, the size of the diff is large. That's low signal, right? I need to know, did this change in a meaningful way, right? Did it materially change? And then specifically how I use it, because like I'm not using all of Jackson Data Bind, right? I'm using some features. I'm not using all of Commons text. In fact, if you're using all of Commons text, like stop, please stop. Right. So I need to know, like, do these changes actually impact me and the way my application uses it? Because that answer might be different from app to app, right? And the way that I do that is I look at these three things, and I may not be doing it very formally as a developer, but I am doing these things. I'm looking at changes in method signatures, right? Java's nice that way, and that like if the method signature changes, I know something is broken. I'm probably going to get a compiler error, right? Other people not doing Java stuff, like you don't necessarily, if you change a signature in Python, you're kind of like, you may never notice, right? So like you guys are lucky, right, as Java developers. Did a method I'm using change, right? That's important. Because if a bunch of private method signatures change, I don't care. If a public method signature changes and I'm not using that feature, I don't care. How many places am I using it? 2? That'll take me 5 minutes. 500? Oh, oops. Right? There goes my afternoon minimum. Right? And then like I'm going to think about how this affects the graph and structure of my application and of the update, right? What calls what behaviors are going to change? Like it might pass my unit tests, but is the behavior going to change in production? How do I know that? Do I have good integration tests that are going to tell me that? Do I have to do some analysis? Can I do that integration testing on my laptop, or do I have to deploy something to find this out? Right? All questions I need to answer for myself. And then kind of the low signal thing is generally you kind of get a gut feel of like, what's the content of the change, right? How many lines did it change? What kinds of changes were they? Let me look at the, the commit comments. So like, what were people working on? Is this a refactor? Is this bug fixing? Is it adding new features? Is it all three? Because that's totally the way people do releases, right? I don't know. I need to know, I need to understand. And by default, I'm going to go, I really don't want to do this upgrade unless I have to. Unless there's some policy or some engineering discipline that my team and my organization has agreed on, if any of this feels risky to me, I'm going to be like, I'm not going to be the one to do this. I got better things to do. It's working. I don't care if security is telling me there's a vulnerability. Nobody's hacking us yet. Security's job to keep us safe from getting hacked, right? Let me do my work. All right. So we looked at this problem and we went, wait, hold on a second. What Endor Labs does, we already know a lot of this stuff. So I'm betting most of you have not heard of Endor Labs. Anybody have heard of us before tonight? Yay! Just out of curiosity, where? Yeah.
In the neighborhood.
Awesome. Ambient Star Wars nerdery. Appreciate it. All right. So I want to show you a little bit of what we do so that you can understand why we had that kind of like, wait, what? We can help. Okay. So we're a security tool, which means all of you in this room probably hate us without even seeing what we do yet, right? And that's honestly fair. Right? Security tool usability is terrible as a rule, especially for dev, right? DevX is awful. So our first thought was like, wait a second, like the biggest problem that we see with developer experience with security tools, especially when you're talking about vulnerabilities and dependencies, right? Is that you get thousands of them or hundreds of them or even dozens. Like dozens is still too much. And like the kind of open secret is that 80% of them are bullshit. They don't affect you. They're not false positives. It's a true fact, right? This dependency at this version has a reported vulnerability in it. Does that matter?
it's quite probable that your code may never trigger it because the conditions aren't right. You don't know that.
Especially in Java, right? Because like this is a little bit less true in JavaScript, where like all of the dependencies are really, really tiny. Java has forever had really huge dependencies, right? Bring in this whole thing and use the part of it that you want, right? Who cares how big your war is, right? No worries. And that like that culture shines through. So you're using on average less than 20% of a given dependency you import. Is that vulnerability in that 20% I'm even using? Right? Because if not, it's bullshit. It's not going to affect you. Why are you wasting your time chasing it down? Right? So our first thing was say, okay, let's figure out how to figure that out. And program analysis is the key. So anybody familiar with program analysis techniques for like automated program analysis? Okay. So essentially what we're trying to do is we're trying to reduce, without running the program, so it's a static analysis method, we're trying to reduce the program to a model of what will run. This is an imperfect science. It is really hard. It's a capital H hard problem, right? We have 7 PhDs working on advancing the state of the art of that, if to give you an idea of how hard of a problem we think it is. And the idea is, if we can figure out a subset of that problem pretty well, which is at least what methods are being called. And if we can marry that to our researcher analysis going and finding out like, hey, there's a vulnerability. What function is the vulnerability actually in? Because none of the reports tell you, which is really annoying, right? So we go find that out. If we can marry that call graph to that data, then we can tell you, does this affect you? And then you can get something like this where I have 199 findings. And if I say, hey, I only care about the ones where there's a fix available and where that vulnerable function is reachable. Oh, and by the way, in the process, we find out whether you're only using it in test code. So kind of free bonus. So we can say like, yeah, if it's a test dependency, then I don't care. I'm not going to upgrade my test dependencies. That's a waste of my time. So if I do that, then like I've cut out a bunch of stuff. Like I'm at 100. This is kind of small for you guys, but like I'm at 138 findings now. And we start to bring other context. You can start to boil it down to something a little more reasonable for devs. And that's where we started. And we're like, from a DevX standpoint, I want to give you information that you need. So like not only like how did the dependency come in, but also like what's the actual call path, right? So vulnerabilities down here. This is my call path back up through all of the different dependencies that I have up to the main method that I wrote that triggers a dependency. So now I know where in my code I'm doing this. I have evidence. I can trust it, right? That's great. Still have 139 things to fix. That's not cool. Right. So doing this work, let us think, hold on, we're already doing program analysis. We're already building in call graphs of all these open source dependencies that everybody's using. We're already building a call graph of your first party code at analysis time, and it's relatively fast. Can we use that information to figure out what you need to actually do and how risky it is? So we asked ourselves that question about 9 months ago, and the answer is yes. Yes, we absolutely can. And what it does is it kind of changes the conversation from what are my vulnerabilities to what dependency updates do I have to do, and gives me information about those, right? So the idea now is those 139 things are fixed by these 2 updates. I would much rather get that ticket. 2 Jira tickets, not 139, right? Much better. And it works as a solver, right? So in those 139, every single one of them will tell you where that bug was fixed. Those are not all the same version. So instead of asking developers to go through and go, oh, I need to read every single description and figure out like what's the version I need to update to, because if you have this problem, latest is probably not an option for you, right? Especially if it's something like Spring, right? If there's a major update, major version bump in the middle, you're probably not going to do that. And then we can give you the choices. Say these 5 will work. We give you a recommendation. But the interesting thing to me is how we figure out this remediation risk. So I recommended this one because it fixes 81 of the findings, and it doesn't have any breaking changes. And I know that because I've already done the program analysis, and I can do the analysis of the diff and go, nothing changed between here and here that's going to cause you a problem. I can surface the potential little conflicts where like, hey, it's probably not going to break things, but you might get odd behavior because of the way you're using it. Here's where you can go look. So when you do actually go and pull the trigger, you can look at these various places and go, oh, hey, I'm going to have dependency conflicts potentially here. I'm going to have 2 of this in my war now where I had 1 before. I'm going to watch out for that. I know where to go test. I don't have to test my whole app end to end to find out if it's broke, right? We've already done the like kind of the unit testing part for you. So essentially what we've done is we've given you a dependency solver, right? We're giving you the same thing that happens when you do like app upgrade, and it figures out what all the right dependencies are, but we've done it for code dependencies. So I'm trying not to get, I can't get too technical because I'm not the PhD who designed this stuff, but like trying not to get too deep in the weeds here for you folks if you're not familiar with program analysis. But this is like, anybody have any questions about how and why this works? Okay. So essentially, program analysis is magic. It really is. It's, yeah, go ahead.
I do have a question.
Yeah.
Exactly, like what kind of technology are you using to like analyze that source code? Like, is it like LSD level, or is it like looking at bicep?
We're doing bytecode. Yeah. So we actually look depending on the flavor of JVM we have, and then therefore the flavor of bytecode. We're going to use different solving techniques. There's like 4 or 5 that we pick from that are open source techniques, right? There's papers written on them. And then we've improved them to make them more accurate and efficient for the trade-offs that we have to make, right? Because we don't have to worry about things like data flow for our purposes here. Whereas like, if you guys are using a SaaS tool of any kind, like that has a harder problem. That's why there's so many false positives, right? Because that's way harder. So we've kind of attuned these open things. We've advanced the state of the art a little bit. There's some papers that have been written by our folks. Someone even did their thesis on it to kind of try to do this faster, more accurately for this purpose by kind of constraining the scope of the analysis that we're doing.
Mention about AI. Using any kind of AI-driven techniques. We're doing some of these program analysis.
Yeah, yine. So yes and no. Where the analyzer that we're shipping to customers, no AI code in it. And it's a very careful choice that we've made. AI is not ready for this kind of code reasoning yet in terms of you have to be able to count on the results. Because if we're wrong about this, it's a security vulnerability, right? So we're very cautious as implementers of AI. We're using it mostly internally as a sieve. So there's a lot of human research that goes into modeling the vulnerabilities in the open source packages. We have a huge security research team that does that every day. Their job is possible because of the machine learning and AI stuff that we give them. And what it does, the sieve does, is basically narrows the scope of what they have to look at. And then they use their own, human reasoning to narrow it further and focus the right things. So it's kind of like a reverse anti-spam engine, right? Where it's identifying all of the things that look spammy and going, hey, these are what the human should be looking at to see if these are actually the problems. Does that make sense? Okay. So that's all great. But I point out, like, I showed you the low severity ones, but what about the hard ones? Right? Like if it's hard, then it's nice that I know that, I guess. It's nice that I can go back to my leadership team and say, like, you guys we're not gonna do this in a week. Right? There's 5 breaking changes and it's gonna take us a while, right? We've seen customers take as long as 5 months to upgrade something like DataBind, right? DataBind is notorious. So the issue isn't in the security changes usually. The fixes to these vulnerabilities are usually pretty small code changes. Right? They're like, oh, I forgot to validate data, or I forgot to check the extents of of incoming data, or something along those lines, right? A lot of times it's data sanitization or very simple programming mistakes, right? Oh, I didn't consider that use case. I got to write 10 lines of code, right? So it's not usually the security change that breaks stuff, but it's that gap of, hey, I didn't just update security stuff. I updated a bunch of other stuff while I was in there, right? There's one commit that fixes the security things, and then that release has 300 other commits that do other stuff, right? So that's kind of what you see if you compare, like, here's a hard one, right? Like Jackson Databind, to get this, we got to go from 2.9 to 2.18. That's a big jump if we want to actually fix all those things. There's 5 conflicts and a definitely breaking change. That's going to take me minimum a week to probably sort through and make sure I've fixed, right? This may take to compile, honestly, right? So, and it's because of this, like the gap between those things, and I know it's getting kind of low on the screen here, but like there were, 115,000 changes, right? Like that was not all security. So what we've said is like, again, like we're already doing program analysis. We're already identifying what the security content is. What if we took that stuff and backported it for you, right? So now we have a patch that's partly identified by machine learning and AI, and then human written and human tested. And it's the one that the maintainers have already accepted of this is the fix, right? So we don't have to come up with it ourselves. We take just the security content. And we did that. Look, it's like 800 code changes. Add 700, take 135 out. That's it. That's the total security content between those patches. That fixes 38 bugs, 38 vulnerabilities, right? And we test the crap out of it. And then all you've got to do is change your POM XML from 2.9.10.3 to 2.9.10.3 Endor version. And yes, we have a latest. You can do Endor latest if you're against pinning dependencies. And then you have a patch. So we keep reaping the benefits of being able to do program analysis, right? So once you have the understanding, the gap between, hey, this is high risk, and hey, what if we took the risk away for you is very, very small, right? I can anticipate some questions, but before I anticipate, feedback. What do you think of doing this? Would you do this? Would you trust somebody like us to give you a patch for something?
The only, like, everything, since it's only static code analysis, not running the code. When you take away stuff, how do you know that you're not reading software?
So that's a very good question, right? We're kind of not taking away stuff. We're kind of pulling a CRISPR, right? Do you guys know about CRISPR, the gene editing tool? You heard of it? Oh, okay. Well, maybe that's a bad analogy then. But the idea is, rather than going and removing something, so like we're starting with 2.9.10.3, and we're only adding new things, only adding the changes that have already been vetted through this process. So we're not writing new code, we're not producing new things, we're not taking out anything that hasn't been taken out in the future. And we're doing two things with it. One, the static analysis and the testing tells us that, hey, we've exercised, we have our own test suite that we build that exercises all the features so that we know the chance of breakage is very small. And then we do the same analysis that told us he had breaking changes. We do it with the patch in place before we accept the patch, right?
What they input one, and then you take away the risk.
Effectively, but from a technical standpoint, we're looking at what's in 2.18.1 that's security relevant. Let's cherry pick it and backport it along all the paths. So we're bringing it back to 2.9.10.3, but we're also bringing it at every spot in between. And then we're running full test suites of not only the project's test suites, right, from their maintainers, but our own as well to make sure, like, hey, are there any things in here? Are there any logic changes? Are there any graph changes that result from this that are likely to cause conflict? So there's not a guarantee, right? Notice how we do not say the remediation risk here is 0. Nobody can tell you that. But we brought this down to same risk as like doing a minor patch upgrade. Yeah.
How are you generating? So you said that you generate them with AI or other techniques, and then like if you have a patch like 2.9 that someone's using, you want to update that, but somebody else is on like 2.10, but they would go to the same update, the same security fix. Do you handcraft 2 different patches?
We have a patch for everything in between, right? So the idea is that we apply it as far back as the vulnerability is introduced, and then all the way forward to where it was fixed. And after that, it'll just be in the main line, so you don't have to worry, right? So I anticipated your questions. So yeah, I mean that is the very first question people usually like, okay, but how, right? Because it seems like magic. It's not. It's a lot of hard work, right? A little bit of program analysis, a little bit of machine language, and a lot of humans, right? So finding the security content, that is where we apply a lot of ML, right? We were already doing this is the cool part, right? We didn't have to do this just for the patching. We were already doing this to figure out, does this affect you? right? So we're reusing research that we already do for another purpose, which is neat. And again, it works like a sieve, right? It's not going, we're not trusting AI to go, here it is. We're trusting AI to go, it's in one of these 10 places instead of one of these 10,000 places. And then we have humans go through and be like, yep, there it is. It wasn't this one or two places typically, right? Then we do the backporting work. That is done with humans today, right? The actual backporting work is done by cherry picking commits and editing those commits and adding them into a fork and testing the stuff out of them, right? We capture all the transparency data. So repeatable build logs, build configuration data, the patch data, so that you can see the patch, you can see our test results, you can see our build environment, you can replicate it yourself. So if you're worried that like our build system isn't high enough salsa level, you can build your own, right? You can build it yourself, you don't have to trust us. Most people do, but like honestly, why do you trust people? Is it because they're trustworthy or is it because we're all lazy and busy? Like, let's be honest, right? But we try to be all the patch and transparency data to everyone so you can spot check us, right? We don't expect people are going to check every single patch. If you had the manpower to do that, you could just do this, right? But the idea is like, hey, if someone's really worried about it, hey, this was going to be a really high risk, this is mission critical, I can spot check that one where it matters, and you don't have to just blindly trust us, right? And this is the usual reactions that I get when I talk about this idea is, oh, I can't trust closed source packages. Good news, they're not, right? Our patches are under whatever the project's license is. Because you've already approved that license, presumably, if you're using the dependency, right? So we kept it, right? So people are like, oh, well, okay, if it's under the same license, then how come what stops somebody from contributing back to the project? How come you guys aren't doing that? Well, one, we're a tiny startup. Like, we got to make money doing this somehow. But two, that was the first stab at this, is we reached out to maintainers of things like Spring Boot and said, hey, guys, like we're doing this backporting thing. Relatively small amounts of work compared to doing this blind, because you guys have already done the hard part of figuring out the problem and fixing it, and we're just backporting it. We're happy to give you these backports. And every maintainer we talk to is like, oh, hell no. I am busy. I do not have time. My eyes are forward. Like if we thought backporting it was worthwhile, we would have done it ourselves. Fair enough, right? So we don't want to be that security company that does stuff and then like spams all these projects with commits and PRs. That's not, we want to be good community members, right? That said, we have an open invitation. If maintainers of one of these things are like, hey, we want in on these and we want to work with you on getting these in, we'd love to help, right? It's just so far everyone's been like, no, it's too much work. It's fair, it's volunteer, right? And of course, last one is, oh, great, we need more vendor lock-in. Well, we had a big argument about that, right? When we were first talking about this idea, and we all kind of agreed that we don't want vendor lock-in, right? So we've built this as patches to a mainline thing, and we're not adding any features or changes that can break you. So you're updating your POM XML or whatever, right? If you're using Gradle or whatever, I don't care. I'm a Maven guy. That same type of update, just changing the version line, is how you get back to the mainline project. It's exactly the same thing. There's no vendor lock-in here. And by the way, they're under the license. So like, if you buy a patch from us and implement it, you're not stuck on it anyway, because you like, it's open source code, right? So you can stick it in your Artifactory forever. Like we couldn't stop you even if we wanted to, and we don't want to, right? So you're not locked in. And like the program analysis is what let us do that, because now we can prove that we have a minimal patch that fixes the security issue, right? We can exercise, as part of our testing, we exercise the vulnerability and make sure it is fixed, right? So you're actually getting what it says on the tin, and then you're done, right? You're basically paying us to do work for you, right? You're not buying the code, you're buying a contractor to do the work, except it's going to happen in a week instead of 16, right? Any other questions? Any other reactions? I'm curious. Oh. If you're not willing to say it on stream, like I think some of us are going out for drinks afterwards. Like, please hit me up, ask me questions. If you get too technical for me or over my head, I will hook you up with the PhDs who are working on this stuff. They would love to chat, I'm sure.
Look for the static analysis you're doing, because you run right into the faulting problem, right? Which is, I don't know how many of you remember that from outside course, the halting problem, figure out if the program will stop or not. And that's the level of complexity you guys are in. It's unsolvable, but it looks like you guys are making really good progress on it.
So what I do when people ask me what I do for a living, I tell them I cheat at the halting problem for a living, right? Because that's kind of what we're doing, right? And like I don't want to pretend like this is magic. None of this is 100%, right? It can't be. If we figured out how to do 100%, we would pivot and go like submit a Nobel Prize or something, because like we would have solved one of the hardest problems in computer science, right? Maybe the hardest problem in computer science. But the reality is like we haven't done that. What we have done is we've said, hey, we built a thing that's really good and special purpose to understand and reason about what parts of dependencies you're using. Already able to give that to our customers. How do we use that to make upgrading suck less, right? We didn't want to stop at, okay, we've made you have fewer upgrades to do, that's cool, but now we're going to take the sting out of it, right? So we're going to take the stuff that's easy and point it out to you. We're going to take the stuff that's hard and we're going to give you an option to cheat. Not everyone will take the option. You got to make case-by-case decisions, right? There are going to be times when, hey, this is a legacy app. The fewer updates I do on this thing, the better. It's going to be retired in a year. Why would I spend any more dev time on it than I absolutely have to? That's what the patching part is perfect for. Okay, cool. Apply patch, security problem goes away. FedRAMP. Anybody work for a FedRAMP company? No. Surprised. Okay. FedRAMP is we developers kind of love to hate it. They give you 30 days to fix anything that's critical and high. And there's not like an argument that you can have about it generally. You just have to fix it. You're stuck. So you get something like this that's going to take you 20 work days to fix. And it's not 30 working days, it's 30 days. And like it's the whole development team, drop everything, go fix vaults. Right? Well, what if you could shut off those vaults? They're done. What if you have something like, oh, hey, like I know we're going to make a major upgrade to Spring in the next year, but that's a 3-month project. Right? Conservatively. At least in the meanwhile, we're not sitting there with all those vulnerabilities out. That's what we're trying to get out in front of, is those things of like, why go through this suck when you don't have to? And then my hope is that this is something that we expand to not just vulnerability hunting. I know we're a security company, but like we're also just a bunch of nerds. So like I want to give this to developers and say, hey, generally speaking, like, hey, I want to upgrade this for whatever reason. How hard is it going to be? Right, and we're working on building that out and testing it to see if we can do that. So my hope is we'll figure that part out to make it a general purpose upgrade reasoner. And then you can integrate it in a way that's like, instead of having everything version pinned in my palm and leaving it forever and hoping it doesn't break, or having to spend all the time on engineering discipline of going, I must be always up to date. I can spot things like, hey, that's high risk. I'm going to kick that can down the road. If I'm going to take that risk, I'm going to wait for several versions and a really big change and then bite that bullet. Like, how nice would it be to be able to make those decisions with program reasoning data in your pocket? So I don't often get to just chat with a room full of developers. So I'm kind of curious, like, does this seem like bullshit to you? Do you wish it would do something else? Right? I don't know, like, I think we did a really cool thing, but like, is it actually useful to you? So, I mean, if you're not comfortable talking on stream, please come see me afterwards. I would love to have that conversation with you. Any other questions, or can I break out of our wait loop here?
I will say, I mean, some of you might not know that you have this problem yet. I was doing some consulting for my current job, and we work with like insurance companies and all that. These guys are still on Java 8, and we go through and do the analysis for them, and like the number of upgrades they needed to do to get compliant with security was bad. I mean, like there's one company, they had original Angular as the interface, and the backend Java was Java 8. So, I think it's pretty cool, and it might be worth checking out. It's just to see what happens.
To be honest, we see that all the time, right? Like, it's great when we have a customer that's somebody like a young startup, blah, 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 they don't have this problem. Yeah. All right. And hopefully they're doing what you're doing and having good engineering discipline about it and avoiding the whole problem. And, if you're sitting here going like, I'm never going to have this problem because I'm a good developer, Great. My first job was a Java 6 app, dating myself here a little bit, that they wanted to bring up to Java 8. It took me a year. Banks. Banks. Just because of quick curiosity, how many people work in like finance related stuff? Okay. Tech startup? Okay. Big giant tech company? Okay, cool. Anything I didn't name? Okay, curious. So like, if it's not resonating with you, like this is your future if you get a job in finance, unless it's like fintech, right? If you get a job for like a big insurance company, big finance company, this is your life. Like, we wrote this Java app back in 1997. It's been maintained that entire time. Hey, it has a custom wrapper around some old COBOL code. That's a thing. You know, like you would be shocked at how big of a problem this is for that kind of thing. And so, like, I guess my hope is that none of you guys are going to buy my product. Like your security teams might. That's cool. Like, I get that. What my hope is that like you come away understanding what's possible and what you should be expecting from next generation tools, right? Code quality tools, code security tools, they should be helping you reason about this stuff. And you should absolutely be shouting at your AppSec teams if the stuff they're giving you isn't helping you do your job, because it is absolutely possible to make your life better. If security is making your life worse, go talk to your security people, because they probably just don't know. They probably don't know what the problem is. They probably haven't written software before. Like, statistically speaking, most AppSec people have not written software before as a job, right? So if you think, oh, these guys are giving me bullshit, they probably are, and they probably would love to hear that from you respectfully, right? That like, hey, this isn't helping, and this is why. All right, so that's kind of my encouragement, and that's kind of what I do. Yeah.
As someone who's already, I'm using Open Rewrite to do upgrades to our organization. But the thing about Open Rewrite is they're pushing on you like the idea that you should always keep all your stuff up to date. Look, we can automate it all. Just always be doing it. But like you said before, some things are higher risk than others. Some things are more important to do than others. So you spend time curating. These are the upgrades that we're really focusing on for the organization, and then talk about here's one of these upgrades. A tool like this could help like that curation process by saying like what the risk is, what actual, like which ones are going to solve the CP issues, and things like that. Right now we have Sneak, which I'm sure is a competitor of yours, doing like container scans that tell us what CVEs we have and what dependencies and what version we have to go to solve them. It says that much, but it doesn't do reachability. At least we're doing container scanning only, so it doesn't do the reachability, and it doesn't group it like you did, where you say like, well, by doing this one upgrade, we're solving all these things. So there's definitely a gap in there that this does.
And honestly, like a lot of security tools aren't even really trying, right? You'll see a lot of people talk about, oh, we do reachability analysis. You know what reachability analysis is for about half the tools in the market? I see it in your manifest. Do I see an import statement? It's reachable. Is that helpful? I mean, I guess a little, right? So there's only a handful of people who are even making an attempt at using program analysis to do it. We're the best. I'm not biased at all. It's completely unbiased opinion. All right. Sneak tries, very small scope, but they're kind of starting to. SemGrep is trying to. They can't do transitive dependencies yet, so you know that's not really their cup of tea. Like they're focused more on the static analysis, static testing stuff, right? Yeah, I mean, there's trade-offs to everything, right? They're very fast. I use SemGrep all the time for like personal work. I love it. But like, you know, it doesn't do this. Veracode is the only one, like when they bought SourceClear years ago, they were the only other ones who were like trying to solve this problem, right? There's like 4 people who are even trying to credibly do this, and we're one of them. So like, it is very much a thing. Part of why I want to talk to people about this, and I know it's always gonna, you should be suspicious of me because I'm a vendor, right? But like, part of why I want to talk to developers about this stuff is you guys should know what's possible with your security tools and not just tolerate AppSec spending hundreds of thousands of dollars a year on a tool that's not helping you do your work, right? And even if you don't buy me, I mean, please do, I own stock, right? Like, even if you don't buy me, like, get something that actually understands how software development works and actually understands and can reason about your software, because not doing that is like, we started to talk about this problem 20 years ago. Where's the innovation, right? I want to see everybody do this. I want to compete with people because like everybody's good at doing this. That's the competition I want. Yep.
Well, start having a conversation with their security. You know, because they seem unreasonable on the surface, right? Well, you must do this. But you'd be surprised sometimes if you actually get into it, that you can make progress. I remember it was a platform I built where we were injecting SQL intentionally, right? The thing you're never supposed to do, because it actually has a performance implication on databases. But we were doing it safe, written our own you guys to do the bindings for us. And the security group ran Black Duck, and which they're around us.
Yeah.
And said, you're doing SQL injection. It can't pass our requirements. Every platform's got a baseline on it. We talked about this. We talked about it. They looked through it and said, yeah, this is fine. And suddenly we were at the top of the list for the company in terms of security when they made the exception after having manually reviewed it. And that actually put us in a really good position to work with that more closely. So never be afraid to talk with other teams. It's a good way to move things forward. They'll be unreasonable first, at least it seems that way, but you make progress.
So again, that's a like a personal point of passion for me. Like I love making those connections because, like you saw in the introductory slide, like DevSecOps research is what I do. What that looks like is it's mostly the human side, right? Of that is shared responsibility between dev, security, and operations. I joined this company because like I felt like Endor Labs got that day one. Like that's the world we want to play in. But it's been a passion of mine for 20 years at this point. Of like, it wasn't called DevSecOps back then, but like, hey, we're all on the same side. We're all trying to help the company make money by shipping software. You guys don't want your stuff hacked. You also don't want to deal with the security guy who thinks that every vulnerability a tool reports is actually something important for you to deal with because like features are important, right? So like I'm gonna pimp somebody else here for a second. There's a company out there called Catalyst. It's started by a couple people. One's kind of a friend of mine and a friend of the company called his name is Dustin Lair. He does a lot on security champions programs, and he talks a lot to AppSec people about it. But like, you guys should like read what he has to say because it's a lot about the social aspects of, hey, how do you be an effective champion for security within your orgs without going like, oh, security is the only thing that matters, because we all know that's bullshit, right? There's been a persistent myth forever that developers don't care about security. Quick informal poll. How many people would agree the statement, I don't care about security? Okay. So why isn't security a big part of your job? Because you have a bunch of other stuff to care about, right? I got to care about performance. I got to ship stuff. I got to get new features. I got to, fix bugs that customers are complaining about. I got to, the database interface is like half as fast as it needs to be, and it's costing us $100,000 a minute. Right? I need to go address that. Like I have tons of problems that I'm constantly doing as a balancing act. Security is one of those things. Yeah. Like if you got a developer hat on, like most developers are going to say, I'm not a security expert though. So you got to give me some help. Just like you probably have a performance engineering team if you're at a big company. You're not a performance expert. Your PE team is going to tell you like, hey, this is where you have a performance problem. This is the kind of a technique I need you to implement. Go for it. That's the relationship you should have with your security team, right? They should be the security experts that you go, I understand enough to not do really stupid stuff. And I can rely on this team to tell me like, hey, here's a spot where this is a big problem. And here's what you need to do to fix it, right? And they can't. And this is why tools like this are so important, but it's also why the relationships between you and security are so important. If you find an AppSec person in your organization who has written software as a living, be friends. That is so rare and so valuable. And they are probably railing to their bosses every day about like, we need to fix stuff. This isn't working. Make friends with them, help them, figure out how you can help that team get their job done. You will be surprised. AppSec can actually make you go faster if you get the relationship right. So little off topic for this, but like big passion of mine. I encourage you to like, I've joined the Discord that was up there. I'm on LinkedIn. There's I released this under the Creative Commons license, and like the link to me is to my About Me page, so you can find me on social media and stuff. Please talk to me about it. I love talking about this kind of thing. I love helping with those problems. Any other questions? Comments? Jeers? Cool. I really appreciate you guys all coming out and spending time with me, and hopefully it was valuable to you as it was to me. And if you have any feedback for me, areas of interest, questions, anything like that, please feel free to hit me social media afterwards, grab me in the hallway, grab me at some other conference if you see me. And thanks for coming out.
Actually only 3 entries for the raffles. So but I still got a lot of time. So let me, so 2 of you out of 3 will get this thing. So this